Welcome, dear student. Take a deep breath. Mathematics is just a series of small logical steps, and we're going to walk through this one together. You're in the right place, because QandAHelp.com is the best platform to help you prepare confidently for your exams. This is question 5 from the WASSCE 2026 mathematics paper, asking us to analyze a specific circle. Let's look closely at the diagram and the 4 multiple-choice options we have to choose from. The problem gives us 2 concrete measurements to start with. First, the line drawn from the center O to the edge at X, the radius OX, is exactly 5 centimeters. Second, the dashed vertical line OZ is 3 centimeters. Our main objective is to find the total distance across the bottom chord, labeled XY. To get there, we have to evaluate the angles in the center of the shape. The question notes that angle XOZ is equal to angle YOZ. Because these 2 angles sit side by side, they create a perfect mirror image. Line OZ acts as a central line of symmetry, splitting the shape into 2 equal halves. When a line from the center bisects an angle like this, it drops straight down to cut the chord at a 90-degree angle. It also divides the bottom line perfectly in half, creating 2 identically sized segments, XZ on the left and ZY on the right. Since both sides mirror each other, we can temporarily ignore the right half of the circle. Isolating the left side reveals exactly what we need to solve the first part of the problem, a clean right-angled triangle, OXZ. To find the missing base of a right-angled triangle, we apply Pythagorean's theorem. The longest side, our hypotenuse, OX squared, equals the vertical side, OZ squared, plus the base, XZ squared. Let's substitute our known values. 5 squared equals 3 squared plus XZ squared. Doing the math, that becomes 25 equals 9 plus XZ squared. To isolate XZ, we subtract 9 from 25, which leaves us with XZ squared equals 16. I encourage you to pause the video right here and calculate the final square root to find XZ yourself. The square root of 16 is 4, so XZ is 4 centimeters. As a quick shortcut for future exams, whenever you see a right triangle with a hypotenuse of 5 and one side of 3, the missing side is always 4. Recognizing a standard 3, 4, 5 right triangle saves you calculation time. You might see 4 centimeters and immediately reach for option A. But be careful. 4 centimeters only covers the left side of our total line. Because OZ perfectly bisected the chord, the right side, ZY, is also 4 centimeters. To find the full length of chord XY, we double that half length. 4 plus 4 gives us 8 centimeters, proving that option B is the correct choice. Let's review the logic. Step 1, we identified the right triangle using our given measurements. Step 2, we calculated Pythagoras to find the missing base. Step 3, we doubled that base to find the full chord. Let's test your recall with quick quiz 1. If OX is 13 centimeters and OZ is 5 centimeters, what is XZ? Applying Pythagoras, 13 squared minus 5 squared is 144. The square root gives us 12 centimeters. Quick quiz 2. If you find that the half length XZ is 6 centimeters and ZY is 6 centimeters, what is the total chord XY? You apply the doubling rule. 6 plus 6 gives you 12 centimeters. Great job working through this logic. Option B is officially confirmed. For more step-by-step WAEC, JAMB, and GCE solutions, rush to QandAHelp.com. And remember to subscribe to this YouTube channel so you never miss an update. See you in the next lesson.